You very much for asking me back again to talk about one of my most favourite subjects, which is the geology of Devon, and particularly the coastal geology. So what I've done here is I've put together a selection of photographs and um, going to talk about how it fits into the age of all the various things we're going to be looking at. And there's a quite nice story here anyway. I expect you'll all recognise this view if you've anything to do with Torbay. There's Thatcher Rock. And this is actually what we call a raised beach. It's an ancient beach at a higher sea level than we have now. And I'll talk more about that when I come to the Quaternary. Right. So this rather gaudy map is a summary of the geology of Devon. It's quite useful for just getting a handle on what's going on where. One of the really just get me pointer up. Sorry, let's see. One of the really obvious things is this, which is the granite, which is intruding through everything else. And this is the Sticklepath Fault, which is the result of earth movements when the Alps, plate tectonics, when the plate which formed the Alps was pushed up, and so there was a lot of accommodation elsewhere. Over here we've got the green sand, this green patch here, and I think it's a bit of a shame that this lot here, which is our wonderful red rocks of Devon, is actually in a funny grey colour, but I guess you can't compete with the granite now, can you? So let's have a look at some of this in detail. This is just a very rough geological timescale, just to give you an idea of the vast timings that we're dealing with. And the oldest rocks that we've got here in Devon are the Devonian rocks. We're very proud of the fact that we're the only British county that has a geological stage named after it. And there's quite a story about how this came about. It was due to when early geologists were trying to sort out the various ages and trying to relate different rocks around the country to their particular timing in the geological column. Yeah, we go right the way along to the Quaternary, which is the Pleistocene and the present day, which is my particular interest. And I'll say more about that in a minute as well. So the Devonian, we've got lovely limestones that you've got in the Torbay area. Those shales, there's some volcanics and some schists. In North Devon, the Devonian rocks are actually, they're not as marine as they are down here in the south. There are a lot of more sort of sands and things up there. Sorry, my clicker isn't working. Carboniferous. The bulk of mid Devon is carboniferous, and those are sandstones and shales. They're quite hard rocks with not a lot of variation in them, just some alternations between these two types. Permian, that's when the granite came in. So it was intruded into these other rocks and uplifted. And I think one of the most amazing views you can have is coming in on one of the ferries into Plymouth. I mean, if you've got good light and you're looking ahead, you can see that great mass of Dartmoor sort of rising up in front of you. It's rather amazing. Then the rest of the Permian and the Trias, they are the red beds, full of fossils, full of structures, lovely rocks. We have no Jurassic in Devon, which is interesting as the Jurassic Coast starts at Exmouth, but there are no Jurassic rocks here. But we do have the chalk, just a little bit of it at Beer Head. The tertiaries, that's the Bovey Basin. They are the areas which opened up when the Sticklepath Fault went in because it's a sideways slipping fault, so it made space. And these filled up with sediment, and it's important for making pottery, making all sorts of ceramics. And then the Pleistocene, and that's where we have the raised beaches I mentioned previously, and there are also drowned forests, and a lot of our rivers were actually formed during that stage as well. I'm going slightly out of order here to look at the North Devon Carboniferous rocks. They're not our oldest rocks. They are rather spectacular, but they don't quite fit with the rest of the story because they're missing in South Devon. But this is Hartland Quay. These are fantastic. Just to give you an idea of scale, that's a person. There's John, my husband, standing there. We, we joke about taking photographs here, making sure you've got a hard hat on. They are, yeah, they do tend to crumble a bit, but those shapes are just the result of enormous pressures from the south, and the rocks have folded, and the pressures are so much that they haven't just folded, they've faulted, they've split, so you've got a fault through here. So enormous pressures and earth movements going on. And this is again from Hartland Quay, but this is looking out to sea, so this is more the sort of thing which you guys will be interested in. You can see that these rocks are all at an angle. We've turned our back on those enormous folds, so this is a part of that sequence. But they're all at an angle, and they're all these nice little crevices, which I guess you will find interesting. You can see as well that you can see the layering, but there are quite sort of massive layers, and then there are these more easily eroded, softer layers in between, and that's purely alternation between the sandstones and then the softer shales going into mudstones. And that is as a result of the environment in which they were laid down, which was shallow seas with pulses of sediment coming in. Just to pop back to this again, just to see where we are. Those rocks we were just looking at are here, and all of this lot is the Carboniferous. Interestingly, they actually affect all sorts of other things. The River Exe flows from up here, sort of down across down to Exmouth, and it has very narrow valleys when it goes across the Carboniferous because it's not easily eroded. You come into these Permian rocks and you get much broader valleys. Bramford Speak, there's a little bit of Tiverton up there, and then the Exeter area itself, much wider valleys. That's not exactly coastal, so moving on. I think the next thing I'd like to talk about is the Devonian rock, so back to the oldest ones. And there are these rather odd ones down in the South Hams, which are that's a fault along there. So there's been some difference in time between the bottom ones being laid down and these others. And in the past, there have been great discussions about the relative ages of these, but they're now thought to be Lower Devonian. It's just a zoom in on the same thing. So this is the Stark complex. Really interesting rocks. That's a person there. And obviously you can see the arm up on here. They are, they've been lightly metamorphosed, so they've been buried at depth. These schists, they've got sort of shiny mica minerals in them. There are a lot of other much softer minerals. This lot here, you can see how easily eroded it's been. You get these fantastic shapes. And the bits that are exposed to the west, where the main winds come from, they tend to, obviously they're going to get the full force of the winds. But if the salt crystals blown on by sort of seawater in the atmosphere, if they dry on these and then they're subject to wind, the salt crystals themselves move about. They make this sort of honeycomb structure. So there's really fantastic shapes you can get. Just another one of the same thing, but I think you get a feeling of maybe up here of how glittery they are. And actually this lot at the top is what I like to say is my stuff. That's the Quaternary. That's slope deposits, which have just sort of things being eroded over a long period of very cold climate. So what are the Devonian rocks that we got? Well, I've mentioned the limestones. This is Torbay. Interesting, the very shape of Torbay. This greeny yellow color, they are limestones. So that's Hope's Nose. That is Berry Head. And the limestones are much more easily eroded. So this is why you've got this shape. These other buff rocks, they actually erode more quickly, but not as quickly as the Devon red beds, which are these things. So the sort of rule of thumb, if you're thinking about buying a property in Torbay and you're worried about cliff collapses, go for the limestone because they don't collapse quite as easily as those red beds. Lovely photo here, which Malcolm Hart let me have. That's an aerial view of Berry Head. But again, obviously this lot has all been heavily quarried, but you can see how that looks really secure, doesn't it? That's a real sort of piece of limestone headland, which doesn't look as though it's going anywhere. But there are some interesting features if you come around the corner, and these are also repeated as you go out onto the seabed and the beach. The grey here, that's limestone, but this red is actually where there are cracks in the limestone, and it's filled with the later red beds. There's some recent work being done on these, trying to work out quite what's going on. Was the split there first, or did the intrusion of all this lot make the splits bigger? Jury's out on that one, but caves in the Brixham area are extensive and important, and not all of them are filled. So the limestones themselves, that left picture is a lovely one which came from the Geopark website, and those are colonial corals. They are broken bits. So those come from the front edge of sorry, there's a clicking. The front edge of a coral reef, and as waves start to wear away at the reef itself, you get bits down at the bottom of the reef. These lot at the top, they're more corals, just little solitary corals. And you see a lot of these actually in building stones around South Devon. And we used to be able to see a lot of them on the Dawlish, on the walk along the seafront there, but the repairs that have been done to the railway line mean that they're not as visible as they were. I think we'd rather have a safe railway, wouldn't we? This bottom one, that's actually from Triangle Point in Torquay, and it's a stromatoporoid, which is it's a symbiotic thing. I'm no biologist, as you can probably tell, but it's related to stromatolites, but it's not quite the same. But it is some sort of algal thing. But they can be really big, and that particular one that's about 6 inches across. And here we are, Triangle Point, with these tilted limestones, and you're looking across at Berry Head here. So you've got both arms of Torbay in this. And this section here, on these tilted limestones, it's an absolutely fantastic place to look for fossils if that's what you're interested in. Though Michael and Toby were telling me earlier that unfortunately somebody's graffitied it, which is a bit of a shame. Now, why have we got this situation where we've got the limestones and then the sort of softer stuff, the limestones here, or these sort of siltstones and mudstones? And the theory is that I've talked previously about earth movements, but the basement rocks, which are these along the bottom here, have had quite a history. They've been stretched and they've been compressed, and this has meant that that they've faulted, they've split. So you get these sort of shapes going on, and they've tilted. So you have high points and low points. The other thing that's happened is that volcanic material has come up, or igneous material has come up through these breaks here. But notice where the limestones are. They're actually on these peaks because they need a certain amount of light. So that's why you've got this, you haven't got limestones everywhere. They're just on the places where these lifted bits of the basement rocks are. This is Waterside Cove. There's Random Head there. Again, there's our red rocks. But Waterside Cove is amazing because you've got both the red Permian, which you can see across it at Random Head there, and Devonian rocks. Now that's, for geologists, that's really interesting because there's no Carboniferous. So that's telling you something about the history of what's gone on there. Maybe the Carboniferous was laid down and then just eroded away, or maybe it wasn't laid down. Very difficult to tell. But there's plenty of evidence for Earth movement. So these are the Devonian rocks. But I don't know if you can see, this lot's folded here. And here, that's the nose of a fold. This lot here is folded. Haven't quite got the nose on this photo. So that's tremendous pressure to make that happen. This bit here, difficult to see on a photograph, but it's actually a continuation of that. And we used to take students down there a lot, and you would have always, you'd stand there and you'd look at the cliff, and you would always find that a student was sitting on that bit there, and you could then embarrass them by getting them to stand up and just sort of show how the thing continued. And if you turn around and look out to sea, you can see these formations continuing offshore. It's quite something. And that's just a look focusing down onto one of these folds. And it shows you the alternation between the much more competent limestoney stuff here and then these muds. I always rather like the fact that we refer to a rock which holds its shape as being competent. That's quite nice. We don't call them incompetent if they don't. But these softer things here, can you see how they've squished? Because the whole thing is folded, everything's got to find somewhere to go. So this lot has really moved, whereas these have split. And you've got these veinings happening where the rock has split and then fluids have infilled. There's a squishy bit in here as well. This again is more of the same, just to sort of show really how much these rocks have been moved about and been faulted and folded. So those were the Devonian rocks. But coming round, you start to see these sort of things, which are full of quite angular, well, I would call them clasts, but bits of rock here. And these are actually Permian. That's a loose block. But as we come round, we see more and more of these. This beach is littered with them. There are also some blocks here which have got very interesting trace fossils, which are the remains of things like burrows. So we don't know what made them, but we know that something was living in this environment. It's interesting because if you've got a lot of these sort of large clasts moving about, it can't have been a very comfortable environment. And this is actually the classic locality at Waterside Cove, where these underneath here are the Devonian rocks. They're not naturally red. They've been stained by the Permian above. And the Permian here are these rocks which are full of all these bits and pieces. Some of them too include bits of feldspar and minerals that clearly originate on Dartmoor. So what we think is that the uplift of Dartmoor has caused erosion all the way around it, and a lot of this stuff has not travelled very far. So a wet day with students again at Waterside Cove, but it's some of this stuff is quite loose, but you can still see the general shapes there. And that there represents the whole of the Carboniferous period, which we can't see. It's not there. Before it got quite so loose, but students used to love to go out there and put their hand on it and say that their hand was resting on 100 million years of Earth history. But we don't encourage that now because it is all rather loose. So just to come back to this, where are we? Whoops, again. Oh, wrong one. Sorry. What we're looking at here is Permian rocks sitting on Devonian. So as I say, none of that's there. So there's a gap, 100 million there. So this is a closer look at some of this stuff. Look how angular that is. Now, to me, that says that hasn't travelled very far. It's not had time to become rounded. There's a real mixture of sizes, so I would say that was poorly sorted. There's some quite fine material there, as well as some bigger bits. It has got a sort of layering in it, which helps us to work out where it may have come from. But I was fascinated when we started off before everybody else came in. We were talking about the flood at Dawlish, and Toby was saying that yes, you could see similar sort of structures in the sediments which have been washed downstream. And I think the take-home message is this sort of formation can happen really, really quickly. Something like a flash flood or a wadi deposit. I mean, we joke that could happen in a Thursday afternoon, maybe a Friday morning, very, very quick. Whereas some of the other deposits that we see could be very old indeed and build up very, very slowly. So what's interesting to do is to look at what we've got and try and just think about how it got there and what sort of environment would have been there then. So this is a real contrast. This is about the same age. This is Dawlish, walking along beside the railway line. And this again is magnificent, though unfortunately the mesembryanthemum has rather taken over, and I don't think you can see all of that at the moment unless they've been down and cleared it. But what you've got here is a dune system, a fossil dune system, and they're wonderful. Look at these. You can see where the winds have changed and dunes have started to form in other directions. And that's quite close to where those flash flood deposits were. And if you think about a present day desert, and this is actually Libya, you see that. You see that in present day environment. So here we are, we're standing on the edge of the sand dunes, but there are these bits of stony desert here as well. And this area here is a valley which quite often has flash floods come down it. So one of the things geologists like to say is by looking at the present, we can start to interpret what might have happened in the past. So here's a nice diagram that came from the Devon Rigs Group. That's the Devon Regionally Important Geological Sites. Now these are interesting geological sites around the county. They're not protected like sites of special scientific interest, but there's a whole load of them being recorded just to help people see what's going on with our geology and nice examples of things. But they did a display for the Dartmoor National Park, trying to tell the story of our geology and how it all sort of interlocks. And I think this is quite a nice one. It shows the granite there in pink, which is it's been intruded into what we call country rocks, but it's also the cover has been eroded. Here the carboniferous rocks that it's intruded into, and Permian here as well. And you start to get these gullies, and that's exactly what we think is happening with those wadi deposits. So that the very quickly deposited materials will be these, but then you've also got sands which take rather longer. The other thing which is interesting but doesn't really affect what you'll be looking at offshore is that where the granite has intruded, you get these baked margins, and you can pick those up around the edge of Dartmoor. And yes, here are these folded and faulted Devonian rocks which are overlain Permian. That's quite nice to see. And this is one, again, just a cartoon trying to make sense of all this by Derek Lamming, who was one of the editors of the book, The Geology of Devon, which we're trying to revise at the moment. But it's the same sort of thing. You've got the Dartmoor upland up here. You've got these limestone ridges. There's a quartzite ridge there as well. And material is coming down slope. This is a bit further round than we were looking at before, but this is the Ness Formation. So we've got Teignmouth here coming round towards Watcombe and Oddicombe. And you've got these amazing bands of material, and it's coarser in the middle and finer at the edges. So if you're walking the coast, you can really start to think about what might have happened, how the material might have got there. But this is a complete contrast. This is slightly younger. This is Triassic, and this is Budleigh Salterton. But I hope you can see immediately how different those pebbles are from what we were looking at previously. And these are the Budleigh pebble beds. And these are not flash flood deposits. This is material that has had a very long history of being moved around, hence it's so round. Normally, if we see something that round, you'd think it was marine, but in fact, it's been proved now that these are actually fluvial, and they're from an enormous river that used to flow from the south. And the material that these pebbles are made of, the original quartzite, actually can be seen on the North Brittany coast. So that's quite a lick. It's also it's fascinating to sort of you turn present day geography on its head, thinking, well, it's an enormous river flowing from the south, flowing north. And these pebble beds extend a long way inland. And there was quite a system of rivers, and you can pick them up around the Nottingham area as well. Fantastic. So just to show a bit more, and I'm particularly fond of that sign. We have a colleague who's been known to stand behind that just wearing a hard hat. But we don't encourage that sort of thing. To look at this lot, can you see there is sort of layering in it? And then there is a line here where maybe the river has changed into another channel. So you can still start to build up quite a picture by looking at structures in the cliff. The other thing to notice is look at the colour of the beach. It's the same material, but it's had all the iron staining of the cement. It's been weathered away. So quite different. Right, back to the map again. Those Triassic rocks we were looking at, that's this little slither here. And yeah, the shocking pink there. It's okay, so we got the Permian. I think as I said before, there is no Jurassic in Devon, but we do have little bits of chalk, and they're these blue here. And this is a view, so move that. This is a view from further around, we're near Seaton there. But we're looking across at Bere Head. And that always looks rather amazing. It's from Sidmouth, certainly. It sort of shines at you if the sun's on it. And here we are, just a better view looking downhill. Again, it's material which was laid down in marine conditions. So you can see there's some layering in it here. It's laid down very slowly. It's made up of the remains of little organisms called coccolithophores, coccoliths and coccolithophores. And it's got flint in it. You get things like sea urchins replaced by flint. There are fossil corals in it. It's fascinating. And just as a little sidestep, actually, I took this. That's the Napoli. And these are, no, that's the Napoli, and these are all the boats that are trying to break it up. So it was rather an exciting time. But looking back, you can see the red rocks here, so you can really get a picture of what's going on along the coast. So that brings me to the bit that really interests me, which is the Quaternary. And that is the last 2 million years. So it's a period when it's often referred to as a Great Ice Age, which is a bit of a misnomer because there were times of it were rather warmer than we are now, and great oscillations in climate. And that has a result, has an effect on sea level, which will have an effect on some of the things that you're seeing. This is a map that came from the Geological Conservation Review on the Quaternary of the Southwest. A few things to point out. These are offshore cliff lines. So again, that's related to changes in sea level. There are more here off the North Devon coast. Interesting that you've got them off both coasts. So it isn't that we're tilting, it's actually that sea level overall has come up. But there also, there's evidence for sea level having gone down. I referred to raised beaches before. So these are beaches which were that are no longer at beach level nowadays. They've been abandoned. The sea has left them. I'll show you Westward Ho in a minute. That's a really good one. Hope's Nose is classic. There is one on Portland Bill. I'll show you a bit around Crawl Point. There's some really interesting deposits there. So that's sort of evidence for sea level fall. You've got evidence for sea level rise from the cliff lines, but also from drowned forests. And you can see those in Torbay and also up here on the north coast of Devon. And people have, over many years, been trying to just sort of sort out the ages of these things. And it's still not, the jury's still out on some of it. Now, this is a classic quaternary wiggle. It's a representation of the sea level change over the last 2 million years. Wiggle matching is now an accepted term in the quaternary, which I think is quite funny. I've seen academic papers with wiggle matching in the title, so that's fine, we can use that. This is where we are now. We're here, and we have reasonably high sea levels. And the other end there, sorry, on my screen I've got your faces, so I can't quite see it. That takes us not right the way back, but it takes us a fair while back over the 2 million years. But what's really key is this oscillation. And there's several other things here. One is that these have been labelled by numbering them, which works brilliantly until you sort of get a bit more data. So stage 5, for example, is now A, B, C, D, and E because it didn't fit what we'd got. But the odd numbers are warm stages and the even numbers are cold stages. And you'll find that quaternary people tend to talk about stage 5E, stage 9, stage 11. And if you've got an odd number, you know it's a warm stage, and if it's an even number, it's going to be somewhere cold. But how this works and how they relate that to climate is if we're in a cold stage, is likely to be more ice, particularly at the poles. So there's less water in the oceans, they're lower sea levels. And the converse. If it's a very warm stage, there will be less ice at the poles, more water in the oceans, higher sea levels. So you can see how that's the melting of ice caps in the present day is causing concern. Because there are a lot of places that higher sea levels don't suit. don't suit us. But the water's got to go somewhere. So this is another view of the Hope's Nose Raised Beach, and this is taken from the sea, and it really shows that you've got these Devonian limestones here, and then you've got this flat beachy deposit on top, and that is it's a mixture of sands and bits of fossil shell, but they're all really cemented hard together. It looks as though you could, they're fossil oyster shells in there, and it looks as though you could pick them up, but you can't. They're very well cemented in. And there is one and some pebbles with a 20 pever scale. There is also a raised beach on Thatcher Rock. It's not quite at the same level, but it's thought to be the same age, and they're thought to be 5E Ipswichian. That's about 125,000 years ago. So not old geologically, but pretty old if we're looking at sort of present, looking at our own history. And the raised beach at Thatcher Rock is actually on the seaside, so looking back towards land, and it's just tucked in here. I've never managed to see it. I know you need to get permission to go and visit. But in the past, Devonshire Association members have been out there and collected fossil shells and analysed them and looked at what sort of environments in which these would have lived. And certainly they all seem to be organisms which like to live in relatively warm conditions, which fits with higher sea level. This one is spectacular. It's Westward Ho, and it's a storm beach. So you would expect it to be at a slightly higher level than present than the sort of bog standard beach. But it's just amazing. And look at those cobbles. I mean, they are really well rounded. So you see what I mean about the bubbly ones. Although we now know the bubbly ones are fluvial. So the roundedness just shows it's had quite a history. It's travelled. It's been knocked about a bit. Interesting work done by Mary Cove, looking at the South Devon coast. And I put this in because I know you're coastal people. But a little bit more detail here on these drowned cliff lines and the raised beaches. She's also got quite a lot of these river deposits in as well. And yeah, the 10-meter shoreline she's got in as well. Head deposits, this particularly around here, we'll have a look at that in a minute. What that is, it was a term used by miners and just meant stuff which was at the top head. But it's now used to mean material which has been subject to freeze-thaw conditions and which has come down slope. But first of all, I'll show you, this is where the drowned forest at Goodrington is, and this actually, believe it or not, that are remnants of trees. There you are, there's a better bit. And Mary managed to get some radiocarbon dates, so they're Mesolithic, between 5,000 and 6,000 years old. And it looks as though there was quite a community, Mesolithic people living around these forests at that time. The fact it's very red suggests that it might be something like alder, which likes wet feet. So we can't be absolutely clear about sea level, water level. Same thing at Hall Sands. Photo sent by a friend who was down there when the beach cover had been eroded off. It's good to go look at these things at different conditions, because sometimes the beach will be completely covered in pebbles and sand, and other times it won't. Now this is one of my favourite places. It's Broad Point, and most southerly part of Devon. So what we've got here, that's an abandoned cliff line. There is another one back here. This lot they're all silts. They're really thick. That's about 8 meters. That's material which has been eroded from back there and further back. And it has to have been cold for a considerable length of time for that to accumulate. So we would say that this happened during a cold stage, and we haven't got any dates on it yet, but it's likely to be from the last glaciation, the last cold stage, which would take us before the Ipswichian I was talking about before. So pre-125,000 years. But there are also rock platforms here. I'll show you a diagram, just trying to pick these out. So you've got the cliffs here and here. You've got this material, this slope deposit, which comes down, and it comes from those, and comes down in between them. Interestingly, they're all on the east-facing part of that area. The westerly side, this stuff just doesn't accumulate. It's it's the weather side, so there's no time for it to build up. And what Peter Keane has done here, he reckons there are 3 different beach levels. So they are rock platforms which will have been sea level will have been at those heights for enough time to make a noticeable change in levels. Now, I've said these slope deposits are cold, and there's a better view of them. We've had a good look at the slot with students, and the bits and pieces in here, the clasts, are definitely material from these rocks, the cliffs behind. It's quite angular, it's not travelled far. And there's John investigating. You can see there is a stratigraphy here. There's a finer layer in the middle. So it looks like several pulses of material coming down. But further around, we found this. Now, I'm convinced, I'll understand if you're not, but we're pretty sure that this material is quite fine, and we think that this could well be, just going to zoom into a bit. It's more, some of these bits are more rounded than others. We think that could be Back Beach because it's different from what else you're seeing there. Let's just see if I can get out of that. Help. Yeah. So if that's so, that represents an older beach, older than the present beach and older than those cold stage deposits which are overlying it. So we just need someone to come and do a little bit more research to try and date it. And what's happening now? Dawlish Warren, well, that's changing, isn't it? I'm sure you're all aware. We like to try and stop it, don't we? They've put barriers all along here. The channel in between Exmouth and Dawlish Warren is continually changing. What's going to happen? We can't protect everything forever. And this is, just to make the point that things do change, this is looking up from just before you get onto Dawlish Warren along the railway line. If you look up, ignoring the mesembryanthemum, there are all these pebbles, and those are the remains of a river channel of the ancient River Exe, and the river used to come out further west. So this is way before we had Dawlish Warren. So just to make the point, these things are dynamic. And this is an offshore diagram done by the Geological Survey. What I'm particularly interested in is this area here. So let's zoom in on that. The Exe, it's formed a really deep channel here, and it's all sort of picking up. It picks up the dart, it picks up the teen, and comes down and around this way. And it's scouring a bit. It's quite deep round here, and we all know what happened in Start Bay. Slapton Lee here. that pebble bed there, that happened when there was a sea level rise about 8,000 years ago. That material isn't being replenished. It was not quite a one-off, but that material was pushed up as sea levels rose quickly at that stage. And of course, the village of Whole Sands was protected by an offshore bank of shingle, which was then taken out to to be used at the dockyards at Plymouth. They thought it would be replenished, and of course, it wasn't. With the effect that that in that village there, well, basically was destroyed. So back to look at the. Don't think I need that one. Oh yes, that was why. You remember I made a joke earlier about if you were going to buy in Torbay. If you're near the coast, it's the red rocks which actually collapse more than the limestones. The limestones are much more resilient. You see the same thing at Sidmouth as well. Yes, Bodicum 2013. Sidmouth, yeah. This is the classic one where the chap living here has lost a lot of his garden, and his garden shed came down not all that long ago. This here is where there was a railway through part of the cliff. You can't see that at all now. That's all come down. So as I say, a dynamic environment. And I was conscious I hadn't said anything about the Plymouth area, and it's not somewhere I've been to very much. But this is from my brother's boat. I was lucky enough to go out with them, and just you can see this sort of shaly material here. It's all it's bedded at funny angles. It's quite complicated. And look at this. There is some folding in here, but it's not easy rocks to work out. But going from looking at these things from the sea, if you get an opportunity to go on the Stuart Line cruises from Exmouth, it's well worth doing to see you can get a really nice view of what's happening with the geology. Um, there's some faulting in here where the this lot, that bed there is actually the same as that lot. This lot has come down, and there've been some earth movements in amongst here. Uh, yeah, there's a little bit here as well. This lot is lower than that lot. They look like the same thing. So from the sea, you can really get quite a nice idea of the relationships between different parts of the cliff. Well, that was a maunder round. Um, I've tried to keep to time, so I hope I haven't scampered over things too much. But I just wanted to give a flavour of all the different sorts of environments our rocks were formed in, and just the great range of what we have. I think Devon's got an amazing array of rocks, and I think we're very lucky to be able to see it. I haven't talked at all about the biology because that's definitely not my bag, but I know that that's what you do, and perhaps just to think about what the rocks might be doing might be useful to you. So I'll stop there.